Hey guys, I want to go ahead and do some more examples for you guys, some derivatives of these exponentials because they can get tricky. The AP exam doesn't have too many of them, but I think these are kind of like freebie questions that we should all be able to get. Now, we're just kind of taking it up a notch. If you notice here, we're going to take the derivative of this guy, and 2x times e to the 4x. So this guy is actually the product rule. So it would actually be the first times the derivative of the second. Well, the derivative of e to the 4x or e to the x is the same thing. So it's e to the 4x times, well, there's a function inside. So, well, the derivative of 4x is 4. Okay. So we got that part. So first times the derivative of the second plus the second function, which is e to the 4x, times the derivative of the first. Well, the derivative of 2x is just 2. Well, we go ahead and clean it up here. Now, these you can multiply here, because these are whole numbers, these are coefficients here. So 4 times 2x, well, that's 8x e to the 4x. Plus, I'm just going to bring this guy over here, 2e to the 4x. Now, you don't need to go ahead and simplify it any further. The AP exam, as long as you get this, I think you should be fine. Because remember, the exam is timed, so you don't have too much time to be simplifying like crazy. Let's go ahead and do the next one. If you notice this guy, exponential 4 to the power of sine of 3x. Well, we know that any exponential, it's the same thing. So 4 to the power of sine of 3x, that's how we start, times ln of, well, the base. On the base is 4. But because we have a function inside, this guy's inside, we got to take the derivative of that using the chain rule. Derivative of sine is cosine of 3x. But inside of that guy, we have something else. We have a 3x, so times 3. Okay, so what I would do, I would probably write this. My final answer would be 3 cosine of 3x ln of 4 times 4 to the power of sine 3x. Okay, so something like that. Next one, number 3. This one doesn't seem too hard. The derivative of sine, well, that's actually just cosine. But remember, just write out whatever's inside. And then go ahead and back and use a chain rule. The derivative of the inside is 2. So the answer is 2 cosine of 2x. Okay, that would be your derivative. For the following one, if you notice here, product rule, you have a function x squared times another one, e to the x cubed minus 1. So we're going to go ahead and use f prime of x is equal to the first times the derivative of the second. The derivative of the second, well, e to the derivative of, well, the derivative of e to the x is just the same thing. So it's x cubed minus 1. But I have a function inside. So the derivative of x cubed minus 1 is 3x squared. Remember, the constant, the derivative is 0. So first times the derivative of the second plus the second, which is e to the x cubed minus 1, times the derivative of the first. Well, the derivative of x squared is just 2x. And let's just go ahead and clean it up now. Can I multiply the x squared and the x squared here? Yeah, you can. Same base. Okay, we're going to add exponents. So this would actually be 3x to the 4th times e to the x cubed minus 1. And we just want to go ahead and bring the 2x in the front. That would be e to the x cubed minus 1. Okay. So not too bad, not too bad. All right, let's keep going. Take a look at this guy, 3 to the power of tangent of x. Okay, well, we know when we take the derivative of an exponential, it's the same thing. 3 to the tangent of x times, well, we need to know the base, natural log of the base, times, well, there's something inside the function. The derivative of tangent is secant squared of x. Okay, and I think you'd probably go ahead and leave it like this. That's perfectly fine. Remember, multiplication is commutative, so it's no big deal. Maybe your professor might want you to write a certain way, but I think this is perfectly acceptable. The next one here, Remember, the 4 is just a multiplier. It's a constant. We can just go ahead and take the derivative of 3 to the power of cotangent 2x. So when we do that, this is just an exponential. So 3 to the cotangent of 2x, well, that's the same thing. Cotangent of 2x. And tack on that 4 because it's just a multiplier. Times, well, we got to take the ln of what? The base, this guy here. Remember, it's just a multiplier. If you want to think about it as multiplying the 4 and multiplying the whole thing, you can. All right. And that would give us ln of 3. Okay. Times the derivative of the inside. Well, the derivative of cotangent is negative cosecant squared of 2x. But then inside of that one, we have something else. Well, times 2. Okay. You can think about it as that. So all I did, this multiplier, okay, I kind of covered them up. This guy just multiplying everything that I'm taking the derivative of. And let me just give myself some space here. There we go. Okay. So cover up the 4 because it's a multiplier. Take the derivative of this guy. It's an exponential, so it's the same thing. Times ln of 3 times the derivative of the inside and the derivative of inside of that. So then this guy would end up becoming a big old mess here. Negative times 4. I can make that a negative 4. And then this guy is times 2. So notice that this guy is a base. Okay, so I cannot multiply it here. But this guy is just a constant, a multiplier. So is this guy. So I'm going to go ahead and multiply that. So that should be negative 8 times 3 cotangent of 2x times, I guess I'll go ahead and put the cosecant squared of 2x times ln of 3. Okay. And that would be it. That one was a pretty long one. But hopefully you guys are starting to get the idea of how to do these. And then I'll just keep making more videos, guys. Hope they help. Talk to you guys soon. Bye.